All right. Hello, everybody. Hope you all are having a wonderful day so far. And thank you for tuning into this month's webinar. I'm Gary Wang, Product Marketing Manager here at Hillstone Networks. And I am joined today by Li Chun, Senior Technical Marketing Manager here at Hillstone Networks. Before we get started, we have a couple of housekeeping items. During the presentation, you are invited to type any questions you may have in the Q&A box. All questions will be addressed at the end of the presentation during the Q&A portion. Finally, this webinar will be recorded and the on-demand link will be posted to our website where you can visit to rewatch. As promised, by saving your spot for today's webinar, you're saving your cloud workloads tomorrow. I'm here today to explain how and why. We'll start by looking at the challenges we're faced with when attempting to secure cloud workloads. Then we'll talk about CloudArmour and its key capabilities, follow it up with some use case examples, and finally end with the Q&A portion. CloudArmour is unique because of its ability to support the past, present, and the future. In the past, monolithic architectures were the name of the game. They were excellent during early stage development. Monolithic architectures are known to be tightly coupled, meaning they operated like those old school Christmas lights. Because the circuits were linked to each other, if one bulb went out, the whole string of lights would be dead. Of course, there are advantages to tightly coupled application development, because it's easier to develop, debug, test, and it's easier to onboard new team members. On top of all this, it was also lower in cost. So then you might be wondering, why then would we ever want to deviate from the structure? That's because monolithic application development structures do not operate with economies to scale. And during the present, applications are becoming more and more complex, and business operations are becoming heavily reliant on applications. In the future, this trend will likely only continue, which is why a CWPP solution like CloudArmour is needed to support the past, present, and future. We've segmented general challenges to 5 sections. First, there is a whole new set of vulnerabilities due to a whole new set of capabilities coming from innovation and technological advances in cloud workloads. Second, container configurations require a different set of compliance standards, making it more complex and more confusing when compared to other workloads. Third, lateral movements amongst workloads are more difficult than ever to detect because of the sheer volume of workloads across the expansive cloud surface. Remember that cloud workloads can exist across a large variety of clouds, such as private, public, multi, etc. To use our own product as an example, CloudHive can provide microsegmentation across VMs. But when it comes to containers, there are different configurations needed, as containers operate differently from VMs. Fourth, more and more applications are being developed as containers. And as mentioned earlier, containers function differently. They are deployed and retired at a much faster rate, so it can be difficult to manage them and difficult to run intrusion detection prevention. A centralized view across the workloads that could automatically be deployed as the workloads are expanding and shrinking would be much more efficient than trying to monitor on a case-by-case basis. We need a solution that can fit with the continuous deployment model. And finally, with different types of cloud environments, not only do the types of protection need to expand, the ability to manage this inflated number of protection schemes needs to improve significantly. Host security challenges are part of the reason for the migration towards the new attack miner framework. Point is, it's becoming quite critical. For starters, with vulnerabilities on the host and software, there exists privilege escalation vulnerabilities in Windows and in Linux. I'll dive a little deeper into Linux vulnerabilities, which begin when attackers initiate a process known as enumeration. Through enumeration, attackers will interact with systems to learn more about the software components, retrieve data from key system directories, and see how the system responds to certain inputs. You can think of it as a burglar scouting out the intended target house. After enumeration, two common methods of exploits are either via exploiting pseudo rights or exploiting the kernel. Let's start by mentioning sudo. Sudo is a Linux program that allows users to run programs using another user's security privileges. Instead of directly looking to gain root privileges, which would be exploiting kernel, attackers could try to compromise a user that has sudo privileges and then horizontally or vertically escalate privileges from there. In terms of kernel exploits, every once in a while, new vulnerabilities are discovered on the Linux system, and attackers will utilize those vulnerabilities to gain root access to a Linux system. It's also known as exploiting the kernel. Kernel exploits can be quite detrimental because the kernel tends to contain key functions. If those key functions are compromised, the whole system will be in peril. Middleware is a key innovation that enables the transition of legacy monolithic applications into cloud-native applications. Microservices scale a lot better than the traditional monolithic architectures. A simple phrase to remember what middleware does and why it's so important is, with middleware, you can build something here in location A, then deploy it in location B, and it will all still work. It provides common services to applications that may not necessarily be provided by the operating system that an application is trying to run on. Put simply, look at your MacBook Pro's USB-C port. It's just a port, but the dongle can connect you to all different types of external devices that aren't necessarily natively available on your laptop. With this added convenience, though, unfortunately, comes more vulnerabilities that it will be subject to as well. This proves to be true in the case of middleware as a common spot of vulnerability in hosts. To the next genre of host security challenges, it is ensuring the environment configurations are compliant. Open ports by themselves aren't necessarily bad, but if ports are left open and the network and security configurations are not compliant, then these open ports become points of vulnerability that can be exploited. Other examples of improper environment configurations include, but are not limited to, improper authorizations being assigned to certain users, or even the simple weak password trope, where passwords are not up to a certain standard and are easy to exploit. Please note, admin is not a good password, especially when your username is also admin. Moving on to intrusion detection difficulty. A reverse shell exploitation is common, and I'll explain it as such. There is a target machine that we're looking to compromise, and there's the attack machine, which let's say I own at this time. The attack machine exists outside of the secure network, and the target machine exists within the secure network that is currently protected by a firewall. Normally, on the attacking machine, we would want to open a shell on the target machine to compromise it and gain remote access. However, in this scenario described, because the target machine exists within a secure network that is protected by our firewall, we as the attacking machine existing outside the secure network will not be able to initiate connection with a secure target machine. However, because the firewall usually only stops inbound traffic and does not stop outbound traffic, we could potentially compromise the target machine if we can get the target machine to initiate the connection with us, the attacking machine. But how would we do that? This is where a reverse shell comes in. To start, on the attacking machine, instead of trying to initiate connection, we would instead open up a listening port, waiting for any connections that may come our way. Then we would find a way to send malicious script, for example, via a phishing email to the target machine. If the target machine is able to open up the phishing email and execute the malicious code, the machine will initiate an outbound connection on the same port that the attacking machine is currently listening on. From there, once the connection is established, the attacking machine now has control over the target machine. The final one to mention briefly here, intrusion detection difficulty, is in light of cryptocurrency becoming more and more popular, there is now also the risk of crypto jacking, which is where crypto miners install malware on unsuspecting devices and utilize the device's processing power to illegally and stealthily farm for cryptocurrency. This form of intrusion can be difficult to detect because it is often done via a remote server, meaning the crypto miners can alter their code to bypass security measures. Finally, with the lateral movement risk, we can start by talking about the layer 2 overlay network. Essentially, it is a virtual network that rests on top of the layer 2 network. This is needed to provide a gateway for VMs to connect back to the physical network, or even bare metal machines. With such an expansive cloud environment, given how cloud-based workloads can be now, it is very possible that lateral movements and jumps will be incredibly difficult to detect. It almost feels like trying to find a needle in the haystack. From the container side, container images are a large point of vulnerability for individual containers. Specifically, if a container is created based on a vulnerable container image, then the vulnerability will now be live and be able to be exploited. Container scanning is available to check for vulnerabilities, but one limitation to it is that it can generally mostly halt known vulnerabilities that have already been discovered. Unknown threats generally can't be stopped simply with scanning. Having runtime security that can activate after the container is running will be crucial for halting unknown vulnerabilities. As it pertains to the infrastructure of containers itself, there are a lot of different compliance standards that it needs to adhere to. This happens because containers often use more open source components, and it accelerates the software development process, which unfortunately results in typical security checkpoints occasionally being ignored. Additionally, some of the new vulnerabilities that are introduced by container solutions may not necessarily be compatible with an older version's configuration management process. Moving on, there are various vulnerabilities we would classify as runtime vulnerabilities. Runtime is the actual engine that runs a container, whereas something like Kubernetes is the management system that orchestrates it all. The first runtime risk is a container escape. Normally, a host's operating system provides a barrier of isolation between the host and the container. But, like the name suggests, a container escape is where a containerized application's vulnerabilities can be exploited so that a malicious attacker breaks past the isolation boundary and attacks the host system's resources directly. From there, the malicious attacker can potentially leverage privilege escalation tactics to gain control over the whole system. Finally, the network side. In Kubernetes clusters, there does not exist a default security policy for the network. This, mixed in with the popularity of lateral attacks in containers, is why the network with Kubernetes can be a huge point of vulnerability. Similar to how the kill chain can be segmented into different stages, this is a similar distribution to the life cycle of a container and how the vulnerabilities slot in. As you can see, majority of the vulnerabilities still rest in the runtime segment of the container, as that is where many of the unknown threats usually lie. Threats are generally divided up into 3 stages: the development and packing stage, the image management stage, and the runtime stage. Development and packing encompasses more of the pre-planning and the creation of the system. For example, how strong of an isolated boundary is going to be created between the host and the container. During the image management section, this is where image templates could be infected. When a container is run, the images being used could potentially be vulnerable, especially those that are publicly available. During runtime, when the container is actually running and services are being provided, there's a whole suite of vulnerabilities that exist, as discussed earlier. In order for container security to be able to tackle all of the challenges listed in the previous slides, and be able to fit into the life cycle stages. We have this graphic, a master template of sorts that we adhere to. Towards the left, which is earlier in the life cycle, there are more static approaches that we can take. After all, at this stage, things are still in development. So during that development process, we can insert forms of security that will be helpful later on in the life cycle. Examples of security we can implement are code analysis, which is essentially careful review and considerations when building the code, and taking precautions when packaging the images and pre-scanning them. Moving on to the image management section of the lifecycle. Some forms of security that can be implemented are image scanning and enabling the idea of a trusted image. The idea of trusted images, to put it simply, is similar to whitelisting. Finally, to the troublesome section of the lifecycle, but also the most important segment, runtime. This section is segmented into two subsections, part of which is the static security and part of which is dynamic security that'll need to adapt on the fly. During runtime, there are known and unknown vulnerabilities that need to be accounted for. Given this whole suite of vulnerabilities that exist in cloud workloads, from traditional bare metal and VM-based servers to the more modernized container-based and public, private, multi-cloud, and hybrid cloud environments, there is an increased need for security protection and risk management, not just on the development side of things, but also on the runtime side of things. CloudArmour can provide comprehensive visibility on all cloud-native workloads and applications, and integrate vulnerability management and compliance across the entire lifecycle of applications. This will ultimately help organizations meet the security demands of new cloud infrastructure architecture, as well as the rapid evolution of DevOps. The CloudArmour Control Center acts as a centralized management system. In this example, say CloudArmour is being utilized specifically to protect the container space. On the container side, Hillstone Security Service modules are deployed. And on the host side, Hillstone Security Service agents are deployed. In tandem, these three pieces of the puzzle will be able to work together. The user will predominantly be monitoring via the CloudArmour Control Center to have a comprehensive view of all assets, flow of traffic, status of key components, and others. Speaking of the CloudArmour Control Center, there is a centralized dashboard that is accessible to users. This centralized comprehensive dashboard can display pretty granular details by utilizing statistical and analytical information for both hosts and Kubernetes clusters. Additionally, on the centralized dashboard is synced up status information that CloudArmour is able to pull, which allows for an integrated vulnerability management and compliance across the entire lifecycle of applications. By combining runtime protection and microsegmentation abilities via our patented traffic steering technology, CloudArmour is able to protect cloud-native applications and workloads, stopping lateral attacks from occurring and implementing zero-trust strategies. As far as intelligent intrusion and prevention, our machine learning enhanced threat detection and runtime protection is enhanced to allow for baseline behavior model. On top of this, CloudArmour also integrates cloud threat intelligence to further enhance threat detection capability. In summary, CloudArmour allows users to see all of their workloads, understand how assets and network traffic interact with each other, and allows users to act intelligently via a smart policy assistant and various policy configuration capabilities. This can result in a cyber-resilient cloud scheme that will work and be able to endure agile known and unknown threats in the cloud space. As mentioned earlier, CloudArmour can monitor both the host side and container side on a granular level via a dashboard view that can switch between a host view and the server view, be it bare metal, VM-based, container-based, etc. In this example, we are displaying a viewpoint from the perspective of a container. This comprehensive dashboard is able to display granular details, allowing for real-time assets management and unified workload monitoring. Real-time access management is a key component of CloudArmour's central management capabilities. It allows CloudArmour to sync up the server assets, in this example, Kubernetes, with the host assets, including data involving images, APPs, services, and clusters, along with information from the host side, such as the operating system, network cards, and other processes. All this information is displayed as basic background information in the dashboard details section. Over to unified workload monitoring. CloudArmour allows for this by possessing a full screen dashboard, which can display both the host assets and, in this example, and on the slide, the container assets. This dashboard can display intricate details on the cloud environment status. As a CWPP solution, CloudArmour is able to continuously monitor and scan for vulnerabilities in VMs, containers, cloud hosts, bare metal servers, and others. It does this throughout the entire lifecycle, triggering alerts as necessary to mitigate risks before they turn into downright threats. For example, as it pertains to container security, vulnerability scanning and image scans are run to ensure risks are noted and attended to before runtime of the application. In effect, CloudArmour subscribes to the idea of CI/CD workflows and integrates security into that workflow, streamlining the integration, delivery, and deployment steps of the application development process. As far as compliance, CloudArmour follows the CIS benchmark guidelines and holds hosts and servers accountable, regardless of what form factor they come in. Additionally, when it comes to these compliance risks, CloudArmour will provide a list of remediation recommendations. The next key functionality of CloudArmour is its ability to allow for visibility into east-west traffic and protection against those types of lateral attacks. This microsegmentation technology adheres to the concept of zero trust network access. CloudArmour performs microsegmentation via its industry-leading firewall technology, coupled with point-to-point network visibility. This microsegmentation can effectively protect against traffic in all directions, north-south and east-west. Additionally, microsegmentation allows security teams to more clearly trace traffic, audit traffic, and just generally speaking, regulate network access, effectively enacting ZTNA in this space. By being loosely coupled to a multitude of cloud platforms and workloads, CloudArmour is able to provide protection while adapting to rapid changes in the differing environments. Additionally, without components being directly related to each other, changes in one or problems in one will not directly affect another. We hope to have a through-and-through solution that will see across all cloud workloads that an enterprise possesses. Effectively, the extensive firewall microsegmentation allows users to segment in the cloud, which keeps viruses under control and reduces other risks in the cloud, helps regulate network access while providing an auditability of sorts, where access and routes can be traced back to their origins. Our next capability of CloudArmour is a staple of our security products here at Hillstone Networks: intelligent intrusion detection and prevention. System calls, file systems, network services, and others are all carefully monitored, be it containers, VMs, or bare metal servers. By leveraging its advanced threat detection, CloudArmour is able to stop threats by behavior. Usually, a baseline of normal traffic and normal behavior is modeled. If traffic or behavior deviates too far from what is deemed normal, the system will generate alerts. By syncing up with threat intelligence, CloudArmour is additionally able to bolster its detection and prevention via signature-based mitigation. We trust in our AI and our machine learning. Tracking all the way back to the 2010s, Hillstone Networks is one of the first vendors to release an AI-based firewall, which is a testament to the maturity of our AI technology at this time. With such a level of granular intelligence monitoring, CloudArmour stops unauthorized privilege escalation, unapproved system calls, and it can keep an eye on any odd runtime behaviors that may potentially be malicious. Paired with our key technologies that are all integrated within CloudArmour is a set of differentiating features that help you maximize the effectiveness of these key technologies. Since I expanded on some of these technologies earlier, I will just run through them again briefly. First, we have the security posture, which is related to the all-inclusive dashboard in CloudArmour. As mentioned earlier, it displays clearly the traffic from the host and from the servers, regardless of the form factor that they come in. Next is a behavior model learning that uses our enhanced AI and machine learning. Finally is a smart policy operation assistant. This follows closely with our Hillstone methodology of see, understand, and act. Specifically, our goal is to help users understand the flow of the network traffic, and then it will help users decide what are the best granular microsegmentation policies to be added. As you can see, CloudArmour reshapes security and allows users to embrace cyber resilience through our differentiated and comprehensive ability to see, extensive comprehension of observations, and granular methodology of acting, which results in security that'll work. A final note I wanted to make about CloudArmour's differentiating qualities is that CloudArmour additionally helps in the re-education process of the cloud security space. This is our duty as a thought leader in the cybersecurity space. CloudArmour follows the simple methodology of seeing assets, understanding their relation and purpose, and acting appropriately to mitigate vulnerabilities. By following this user-friendly and simple process and visualizing it, it helps provide insight for non-security professionals to see what we do in cybersecurity and how exactly cybersecurity investments truly benefit an enterprise. As CloudArmour was released over a year ago, we do have a couple of use cases that we can share with you all. First is a huge bank in the finance industry with reported revenue of close to 30 billion US dollars. What happened in this scenario is that in the Kubernetes cluster, in order to view the east-west traffic, the structure was set up where it first had to be translated into north-south traffic to the external hardware-based firewall before microsegmentation could be implemented. Naturally, this would prove to be rather inefficient because there would be some network delay during this cumbersome process. Policy changes would put pressure on the management of the firewall. To top it all off, workloads were really diverse, ranging from containers to bare metal to VMs, just overall adding to the complexity of the situation. Hillstone stepped in here with CloudArmour because as a cloud workload protection platform solution, CloudArmour is able to account for the assets regardless of form factor. Additionally, CloudArmour could handle the east-west traffic internally, which reduced workload on the external hardware firewall. On top of this, the policy management process was greatly improved by the implementation of CloudArmour's smart policy operations. We'll share one more use case, as this one differs slightly. The situation was for a state grid in the energy industry. What happened here was when containers underwent source network address translation to go out to the internet, external firewalls would lose visibility of the source address, which was a big potential liability. Additionally, the external firewall present had no east-west traffic visibility. Finally, the cluster was lacking runtime security control and did not possess any insight into abnormal application behavior. In this situation, Hillstone stepped in with CloudArmour because it could help solve the pain points. CloudArmour's comprehensive north-south and east-west visibility, microsegmentation capabilities, application and container behavior modeling, and others to name a few, could help out greatly in this situation. Effectively, Hillstone was able to implement zero trust policies for this client by deploying CloudArmour.